All right, so this week we're going to look at 2.2. Okay, that's on what we call a unit circle trig. So this will be the first section in this class where we learn the names of all the trig functions, like sine, cosine, tangent. You've probably seen them before. If you've done SOHCAHTOA, like opposite over hypotenuse, adjacent over hypotenuse, this is a little bit different than that. Okay, we're going to do SOHCAHTOA stuff next academic week. So this is unit circle. Has anybody done the SOHCAHTOA, adjacent hypotenuse, that stuff? Okay, so we'll talk about that more next week. All right, so for this week, I'm going to start just by looking at that diagram. Okay, so what I've drawn is a circle. Okay, and going around the circle, I've labeled angles in degrees. Okay, going counterclockwise, 0, 90 at the top, 180 on the left, 270 on the bottom, and then 360 would be all the way back at 0 again. And the type of circle here is a unit circle. Okay, everything that we do up until like the very last thing, I think in 2.2 part 3, is going to use a unit circle. Okay, what a unit circle means is that the radius is 1. That's all. If you're like, well, 1 what? 1 anything. 1 inch, 1 foot, 1 mile, whatever you want it to be. Right? But it's 1 unit. Okay. Any questions on that diagram? All right. So the whole goal with unit circle trig, I have it written out down below, but let me just show you first. Okay. Let's say that we put a point somewhere on that circle. Okay, like here. It doesn't matter where you put it. You can put it anywhere. That point has a coordinate. Okay. We don't know the coordinate, but there is a coordinate to get to that point. Okay, right? So starting from the origin, that's 0, 0, you go over a certain amount, and then you would go up a certain amount. The amount you go over, that's the x value. The amount you go up, the y value. Okay, any questions on that idea? Okay, so the big idea is that for any point you put on this circle, wherever you put it, there's a coordinate that represents that point. That's what you're trying to find. What is the coordinate for that point? What's the x? What's the y? Now, we can't find the coordinate for just any random point. We can only do it for certain ones. Okay? And it turns out it's pretty easy to do it if you do it for angles of 45, 30, and 60, or any multiples of those. So like 30, 60, 90, 120, anything that's a multiple of 30 or 45. If it's a multiple of 30, it's automatically a multiple of 60. Okay. And those are the kind of angles that what I'm going to teach you this week, you can use what I'm teaching you for. Angles that are multiples of 45 and 30. If you have an angle that's not one of those multiples, unit circle trig is not really the way to do the problem. Okay? So if you said to me, find the coordinates for a 17-degree angle, well, if I got out a protractor and measured a 17-degree angle, maybe it would be about like that. It's a little bit past 0. But to find the coordinates for that, it's going to be very difficult. So 17 degrees is not something we would do with unit circle trig. We just use a calculator. All right. So now just to kind of put all that in words, every angle that you can think of, specifically ones that are multiples of 30 and 45, can be represented as a coordinate on a unit circle. When I say every angle, I really mean multiples of 30 and 45. Technically, if you really wanted, you can find the coordinate for anything. Like even 17 degrees, you could find the coordinate for it, but it's going to be awfully messy. It's not really the point of unit circle trig. Okay, so we'll stick with multiples of 30 and 45. So there are two ways we can measure angles. Okay, motion on a circle can go clockwise or counterclockwise. Okay, and I think we mentioned this last week. But if you move counterclockwise, that's a positive angle. Counterclockwise equals positive. Okay, well, if counterclockwise is positive direction, Lexi, what would the other way be, clockwise? Negative. Yeah, it would be negative. Okay, and I've got a little diagram, kind of an interactive thing. I can just show you that idea. I think it's the same thing we looked at last week. All right, so let's take a look at that chart or that little diagram where I can kind of draw angles. All right, so in this program, all I can do is move the terminal side. I can't move the initial side. And it doesn't give me the coordinates in this program. So this we have to learn how do we figure that out. But I'm just trying to show you that if you go in the counterclockwise direction, you're generating a positive angle. If you go past 360, we start to get into angles that have more than one revolution. But we don't really care how many times we go around. All we care about is where does that little red circle stop. So for the purposes of unit circle trig, 450 degrees and 90 degrees would have exactly the same coordinate because they both stop right on the positive y-axis. Any question on that idea? And that's going to be kind of important because if you get an angle that's really, really big, like say it's like 2,500 degrees, well, what that means is you've gone around a bunch of extra times. So you just take the number that they give you, and we can keep subtracting revolutions until you finally get to a number that's small enough to work with. Okay, if I had stopped right on 90. Now, same idea if we go the other way. If we go in the clockwise direction, now we're generating negative angles. The top number is degrees. What's that bottom number? That's radians. Okay, we talked about converting between the two last week. So we can go around, and then if we make more than one clockwise revolution, now we're looking at an angle that's getting more and more negative. Right? So if you asked me to do unit circle trig with a negative 540 degree angle, the first thing I would do is add a revolution, and then I would even add one more. So for the purpose of unit circle trig, negative 540, positive 180, same spot. But to me, positive is always easier to think about than negative. Okay. So the next part I kind of already showed you in the diagram. If you get an angle that's too big, okay, you've gone around too many times, what did I just say you could subtract from it to make it smaller? Yep. Alan?
You said one revolution, which is 360 degrees.
Yep. So if you get an angle that's greater than 360, or even equal to 360, just subtract 360 as many times as you need to till you get your angle smaller. Now, when should you stop? Stop before the angle goes negative. Okay. Try to get your angle between 0 and 360. Okay. Now, if they give you a negative angle to work with, again, I think negative angles are confusing because you've got to think about going the other way. So we're always going to take the negative angle and turn it into a positive angle before we even start unit circle trig. Just to make the thing that we're working with easier. So, to make a negative angle positive, you can add 360. You add revolutions as many times as you need to. But you don't want to keep adding 360 and then your angle gets huge. Right? Stop once your angle is between 0 and 360. Okay, so that's always the goal. get an angle between 0 and 360. It's going to make life easier to do unit circle trig with. Also, another thing that might make what we're going to do easier is degrees. Maybe if you get an answer or you have a problem that's in radians, like this one. We'll find the 6 trig functions of 11 pi over 2. Well, the whole goal of unit circle trig is to find a coordinate. So you have to figure out the coordinate for that 11 pi over 2. But maybe it would be easier to think about it in degrees. Okay. So that'll be one of the last ones we do. Okay. Any questions on that? All right, so that's the first step. Make your angle easy to work with. Now we can start unit circle trig. So I said to you earlier that the goal is to find a coordinate. Find an x and find a y value. Once you find the x and the y value, you're going to plug them into a formula. Which formula you plug them into depends on which trig function they ask you about. There's 6 different trig functions they can ask you about. Okay, here's the first 3. Sine, cosine, and tangent. And we're not defining these formulas using opposite, adjacent, and hypotenuse. That's right triangle trig. This is unit circle trig. So these are going to be defined in terms of a coordinate. You're either going to need an x value, a y value, or some formulas you might need both. So if they ask you a problem about the sine, all you need is the y value of the coordinate. If they ask you a problem about the cosine, you need the x value. And then if they ask you a problem about the tangent, you need both, and you divide them. Take the y and divide by the x. Now, I didn't put this in. It's up to you if you want to write it, but you technically could make y a fraction by putting it as y over what? You could put it over 1. The only reason I'm going to show you that for a second is because the other 3 trig functions, all you have to do is flip the first 3. So if you know the first 3 and you flip them all, you get the second 3. Well, the bottom one would be easy to flip because that's already a fraction. But the other 2 weren't. So if you want to think of sine as a fraction, what do you get when you flip y? 1 over y. That's your cosecant. Okay, in a second, I'll show you the abbreviations because we normally don't write these out like this. There's 3-letter abbreviations for all 6 of these. Brady, how about the secant? What do you think that one is based on the pattern I just explained?
1 over x.
Yep, it's 1 over x. And then the cotangent. Abby, what do you think the cotangent would be?
X over y.
It's x over y. Yep. So all you have to remember is sine is y, cosine is x, tangent is y over x. If you remember those 3, then just think in your head, flip them. That's the other 3. All right, so the abbreviations. Let's start with sine. Does anybody know the 3-letter abbreviation for sine? Yep. Jillian?
S-I-N.
Yep, S-I-N. Most of them just use the first 3 letters, but we'll see. We run into a problem with that in a little bit. So sine. How about cosine? Anyone know the abbreviation for that one? Yep, Lauren?
C-O-S.
COS. And the abbreviation for tangent. Yep.
TAN.
TAN. In fact, all the abbreviations just use the first 3 letters, except cosecant. Why do you think we don't use the first 3 letters to abbreviate cosecant?
They're already used in cosine.
Yeah, we already used it for cosine. So we just basically use the first letter of each syllable. Co, C, can't. CSC. The The first three you'll see buttons on the calculator for. If you have a scientific calculator. We're not using a calculator at all today, but I'm just showing you that the buttons are there. The other three buttons, or the other three functions, CSC, SEC, COT, there's no buttons for them. All right, and the four angles that I labeled originally on this diagram are called the quadrantal angles. 0, 90, 180, and 270. Because they all fall right on the axis, and the axes are what break your plane into quadrants. So let's just see if we could come up with the coordinates for 0, 90, 180, and 270. Okay, so remember, this red dot that I just colored black, that's the origin. That's 0, 0. And the radius of this circle is 1. So, does anyone have a guess what the coordinate for 0 degrees would be? Well, how about Colby? How many units are you moving from the origin to get from here over to there? How far? Yeah, you're moving 1 unit. And which way did you move?
To the right.
1 unit to the right. So if you're at the origin and you move 1 unit to the right, what's the coordinate if you just go 1 to the right?
1, 0.
1, 0. Yep. So that's the coordinate for 0 degrees. That never changes on a unit circle. Okay, let's do 90. Now that we went through that one, anyone have a guess what the coordinate for 90 is?
0, 1.
Yep, 0, 1. The quadrantal angles are the easiest coordinates to work with. They're all 1s and 0s, or sometimes there's a negative. Okay, how about 180? That would be the coordinate for 180. Do you like?
Negative 1, 0.
Yep, negative 1, 0. And then the coordinate for 270, 0, negative 1. Every other coordinate on the circle is going to have fractions or decimals. Okay, those are the only 4 that are really, really nice numbers. Okay, any questions on those coordinates? Okay, and again, those angles that we just labeled, those are called the quadrantal angles. All right, so we got our trig functions. So now we've got our formulas. So how do we actually do unit circle trig? Well, the very first step is to find the coordinate. You already have the coordinate for 0, 90, 180, and 270. We just did them. So you should never have to think about those ones again. That would just memorize what those are. So step 1 in unit circle trig, find the coordinate. If they don't give it to you. Okay, I'm going to start you off with a couple problems where I already give you the coordinate, so you're not even going to have to do step 1. But if they don't give you the coordinate, you have to find it. If you don't have it, you can't do unit circle trig. Okay, so find the coordinate. Now you're going to have an x and you're going to have a y value. Use the x and the y value in the definitions we had right here and plug in the x and the y into one of the 6 formulas. They'll tell you which function they're going to ask for. On the test, I'm going to ask for 1 trig function per problem. When we practice in class, I'm going to do all 6 per problem. So we practice the sine, the cosine, how we do them all. Okay. Okay, and as far as notes and kind of explanation, that's really it. Okay, all I'm going to do for the rest of class is probably like 7 or 8 examples, and that'll be it. So we're going to start with some kind of basic problems today, where I give you the coordinate for some of them, and then I'll give you some easy ones where I don't give you the coordinate. Then tomorrow we'll get into some ones that are a little harder when you don't have the coordinate. I will continue that on Wednesday. Okay, everyone have the 2 steps? Nope? All right, I'll leave them up. Okay, so in the first problem, they are giving you the coordinate. Sometimes you are given the coordinate. In this problem, you are. The coordinate is -1/2, comma, square root 3/2. Is -1/2, comma, square root 3/2, is that the coordinate for 0, 90, 180, or 270? Is it one of those 4 coordinates? What do you think, Cut? No. What did the coordinates for the 0, 90, 180, and 270 all look like?
They were all involving the number 1 in some way.
Yeah, like a 0 and a 1, or maybe a -1. They didn't have square roots in them, and they didn't have fractions like a half, -1/2. So what that means is this coordinate is a coordinate for some other angle. What is the angle? I'm not going to tell you. You don't need to know. All you need to know is that's the coordinate for something. We're going to use it to find all 6 trig functions. That's the x, that's the y. And if you're thinking, well, how can you do the problem if you don't even know what angle that is? All you have is the location of it, not what it is. Well, it's the same way you could describe what somebody looks like without knowing their name. You don't have to know someone's name to describe their eye color, hair color, height, what color shirt they're wearing. You can describe a bunch of things about them without even knowing their name. That's basically what we're doing. Describing a bunch of things about the angle without knowing how big it is. Okay? But we know where it is, and that's what we really need to know. Okay, so let's start with sine. Sean, what was our definition for sine?
y/1.
Yep, or we could just simplify it to y. Yeah, so it's really just y, and what's the y value here?
Square root 3/2.
That's it. So that is the sine of some angle, which we don't know, but that's the sine of it. It's the square root of 3/2. Okay, let's look at the cosine. Pacey, what's the definition for cosine?
It's x,
X. And what's our x value here?
-1/2.
-1/2. Okay. So that's the cosine of some mystery angle that's located at that coordinate. And let's do tangent. Ben, what's the formula for tangent?
y/x.
It's y over x. So we're really just dividing the 2 we just had above it. Y, square root 3/2. Divided by x, which is -1/2. Now, when you divide 2 fractions and you have the same denominator, what happens there? It cancels out. Some people say, well, you take the bottom and you flip it, right? Keep the top, multiply it by the reciprocal of the bottom. Well, if you did that, the 2 would go to the top and you would cancel the 2's. So I just cancel them out right away. And all I'm left with is the square root of 3 divided by -1. That's the negative square root of 3. Any question on that one? Right, so that's really the hard part, because we've got the 3 on the left. Austin, do you remember what I said to do with each of the ones on the left to get the ones on the right? You just flip them. Okay, so cosine is going to be a really quick one to flip. So my secant is -2. Let's do the cosecant. Nathan, what do I get when I flip the sine to get the cosecant.
2 over the square root of 3.
Yep, so that's a good start. Now, why did I say that's a good start? Why not just circle that and say, okay, we're done? Luke?
Can't have the square root in the bottom.
Right, we can't have a square root in the bottom. So you remember what we multiply by to fix that? No? Anyone help them out? What do we multiply by to fix having that square root? Yep, Alan?
The square root of 3 on the bottom and the top.
Yep, square root of 3 over square root of 3. In the top, that's going to give me 2 times the square root of 3. And then in the bottom, the square root of 3 times the square root of 3, that's the square root of 9, which is 3. So now we're stuck with the root in the top, but for some reason that's okay. They just don't like us to leave it in the bottom. Any questions on that one? Okay, and the last one, cotangent. So Emma, to get my cotangent, which trig function am I supposed to flip again?
It's going to be x over y, so then
So which, you just flipped the, which trig function? Not sure. Anyone help her? Which trig function did she flip to get that? Yeah? Yeah, you flip the tangent. Now, if we want to flip the tangent, okay, the problem is it's not a fraction right now. So what could we do to make it a fraction?
Put it over 1.
Just put it over 1. And now just flip it. And then if the root goes to the bottom, we fix it. So if you're thinking, well, why don't we just go back and do x divided by y? Because I've already simplified that a little bit. I canceled out the 2's. If I go back and write it as x over y, I'm going to have to cancel the 2's again. So I just take whatever I wrote on the left and flip it. Because if it already has some stuff reduced, that makes life easier. So when we flip it, negative 1 over the square root of 3. And Liz, what do I have to multiply the top and the bottom by to fix the root in the bottom here?
square root of 3.
Yeah, it's the same thing we just had up above. We had 2 over the square root of 3, now we have negative 1 over the square root of 3. So it's the same steps. Multiply the top by the square root of 3 and you'll get that. Bottom, you'll get that. So there's the 6 trig functions for the coordinate I gave you. On the test, that would be 6 separate questions. I'm not going to ask you to do all 6 in the same problem. Any questions on that one? It does take a little bit of getting used to working with the roots, but you're going to see the same roots come up over and over. Square root of 3 comes up a lot, square root of 2 comes up a lot, and the fraction 1/2 comes up a lot. Other than those numbers, the only ones that are going to come up are 0s, 1s, and negative 1s. So once we learn a little bit more, the pattern is very predictable about which numbers come up a lot. All right, so let's look at this one. It says find the 6 trig functions of some angle. Again, I'm not telling you what the angle is. I'm calling it theta. But there's the location of it. It's square root 2 over 2, comma, square root 2 over 2. Now, this one, I bet someone can figure out what the angle is. You don't need it. But if you think about a circle, and you've gone right the same amount you go up. They're the exact same values, x and y. Does anyone know what kind of angle that would give me? If I go right and up exactly the same amount. Yeah,
45.
it is. That's the coordinate for a 45-degree angle. You go right and up exactly the same amount. Do you need to know it's a 45-degree angle? No. You already have the important thing, the location. Tomorrow, we'll talk about how would you figure that out if they didn't give it to you. Right, so let's go through our six trig functions. Sam, can you tell me what my sine would be?
Square root of 2 over 2.
Yeah, and can you tell me which one you picked since they're the same, just to make sure we got the right one?
The second one.
Yes, you picked the y, which is correct. So there's your sine. Ryan, how about the cosine?
Square root of 2 over 2.
Yep, that's also square root of 2 over 2, but this time it's the x. So if you mixed up the x and the y in this problem, you'd be okay, but in general, you don't want to do that. Okay, and Justin, what's our formula for tangent?
Y over X.
It's y over x. Now the y and the x are the same. So what do you get when you divide two things that are the same? 1. And now, while I did the tangent, I could do the cotangent pretty quick because all I have to do is take the number 1 and flip it. So Jillian, if I flip 1, what do I get?
Wouldn't just be one.
Just, yeah, it would just be 1 over 1. When you flip 1, it stays the same. All right. So Brianna, to get the cosecant, which trig function do I flip?
So be 1 over y, so
Yep. So you've just flipped the which trig function?
sine.
Yeah, flip the sine. Right? So if you take that and flip it, that gives you 1 over y. Remember, 1 over something just means flip. That's all 1 over something means. Flip. So we get 2 over the square root of 2. But we've seen that before. And Raisha, what would I do with that?
With what?
With that?
Multiplied by square root of 2.
Anything else?
Yeah, you do it twice.
Yeah, multiply by square root of 2 over square root of 2. That's going to give me 2 square roots of 2 in the top. In the bottom gives me square root of 4, which is 2. And then any number that's the same, if it's on the outside of the root, you can cancel it. Bless you. Okay, so I'm just left with the square root of 2. And what about the secant? What's the secant going to be? Yep, Alan?
It'd be the same thing.
Right, it's the same thing. If the sine and the cosine are the same, so are the secant and the cosecant. Any questions on that? So those are the 6 trig functions of a 45-degree angle. Again, you do not need to know it's a 45-degree angle. You just have to know they gave you the coordinate. You have to know the 6 formulas to plug in. All right. Okay, why don't you guys try that one? Okay, this will be the last one we do where I give you the coordinate, then we'll do some where you have to find it. Okay, but take a couple minutes and try that. I think the hardest thing is just the arithmetic with the roots. You got to make sure you do that stuff right. All right. So as I said before, I think in this one, toughest thing is probably just the work with the roots. The sine and cosine should be pretty quick because there's nothing you need to do. You just have to copy the right part of the coordinate in the right spot. So Brady, what's my sine?
-1 over 3.
Yep. And if you wanted, you could do the cosecant right now real quick because that's just a really easy one to flip. When you flip it, keep in mind the negative doesn't change. If it's negative before, it's negative after you flip it. Cosine. How about Abby?
It's 2 the square root of 2 over 3.
Yep. So 2 root 2 over 3. And now the tangent is when you take y divided by x. So what I do visually is I just pretend like I put a fraction bar right there, and that's the problem for tangent. So what would cancel out first? Yep, the 3's. So I would be left with -1 divided by 2 square roots of 2. Now, the only thing you can't leave in the bottom is the square root of 2. The 2 in the bottom is fine. So don't do anything with the 2. All you have to fix is the square root of 2. So in the top, you get negative square root 2. In the bottom, what's the square root of 2 times the square root of 2? Laura?
Square root of 4.
Square root of 4, which is?
2.
So you get 2. When you multiply those together,
4.
times another 2, and we get 4. Any questions on that? Did anybody get -2 over the square root of 4 for that one? That was a little tricky. Yeah. Okay, and now we just have to flip them. So cosine, I'm going to get 3 over 2 root 2. But to fix it, I'm going to have to do exactly the same thing I just did before. Multiply the top by square root of 2 and the bottom. We already know what you get on the bottom. We just did it. You get a 4. Right. And for cotangent, well, you've got 2 options. You could flip what I just circled, or you could go back to what we had before we fixed the root in the bottom. Which one of these things do you think would be better to flip?
The one on the left.
Yeah, how come? I mean, they're the same. The 2 things I circled are exactly the same answer. But why is the one on the left better to flip?
Because the root comes in on the top.
Right. If you flip the one on the left, before we fixed it, the root is going to go to the top automatically. If you flip the one on the right, the root goes back to the bottom, and then you have to fix the whole thing again, and you're going to get the same answer. So it's going to be a -2 square roots of 2. Okay. Any questions on any of the arithmetic here? All right. So what's a little different about this one? There's no coordinate. Okay, they've given you an angle, which is great, but that's not what you need. You have to figure out the coordinate for 90 degrees. So either you have it memorized, or make a quick sketch, put 90 degrees, and hopefully that jogs your memory of the coordinate. Does anyone remember the coordinate for 90, Lauren?
0, 1.
It's 0, 1. Now we go ahead and do all the same stuff we just did before, but the numbers are going to be much, much easier to work with. Great. So Cassandra, what would be my sine? Yep, sine is 1. Tiana, how about the cosine?
0.
Yep, 0. And now the tangent is y divided by x. What is that?
Undefined.
Undefined, yes. It's one that a lot of people just mess up. But when you take 1 and divide by 0, remember you can't divide by 0. A number divided by 0 spells no. No, you can't do it. So you write undefined. All right, let's go to cosecant. Colby, what would my cosecant be?
1/1.
Which is?
1.
Yeah. So just take the sign and flip it. We said that earlier. Flip 1, stays the same. Now, we wrote cosine is 0, but if we wanted to make it a fraction, Jordan, what could I do with that? How could we make 0 a fraction? Wait, Jordan. Jordan's not here. You're Luke. I'm sorry. Luke, how could we make 0 a fraction?
0 over 1.
Yeah, we could put 0 over 1. And now, when we flip it, we get 1 over 0. We just talked about that. 1 over 0, undefined. Okay, and the last one, cotangent of 90. So we're flipping undefined. Okay? You're taking what you have here and you're flipping it. If you're like, well, wait, what was undefined? It was 1 over 0. So when you flip it, what happens to 1 over 0? It turns into 0 over 1. And what is that? That's 0. If you take $0 and divide it between one person, they get 0. You can do 0 divided by 1. Okay. So when you do trig functions for the quadrantal angles, your answers are always going to be 1s, negative 1s, 0, or undefined. Those are always the 4 answers you get.
What's the cosecant sin? Is that a...
The cosecant, that's a 1. Okay. This one, I think we're getting the hang of doing all 6, so let's just do 3 of them. We'll do the sine, the cosine, and the tangent of 3 pi. Okay, so now in this one I did another little twist. What's different about this one? Besides the fact you don't have the coordinate. That's the same as the last one. But what else is different? Eden, can you tell me what else is different?
You have to multiply it by 3 pi.
Okay, can you talk more about the 3 pi? What are you thinking about that? That's like my 90 in this problem. That's my angle. So
It was radians.
it's radians. So if you can work in radians, that's fine. If you're more comfortable working in degrees, then we might want to change it to degrees first so we can see where it is. Okay, so how do I change radians to degrees? What do I multiply by? Yep, Lauren.
The pi on the bottom and 180 on the top.
Pi on the bottom, 180 on the top. 3 times 180 gives me 540. Okay, so now I have an idea of where I am in degrees. But there's something I still don't like about 540. What do you think I want to do with that? Yep. Ethan?
Take 360 away from
Yeah. We've gone around an extra revolution. For the purpose of unit circle trig, all we care about is where it stops, not how many times it went around. So we'll subtract 360, and that's 180. So now if we can figure out the coordinates for 180 degrees, that's how we answer this question. Nathan, where is 180 on that circle?
Left middle.
Yeah, it's the left, right there. And do you remember the coordinate for 180?
-1, 0.
-1, 0. Now we can fill in our sine, cosine, tangent. So Austin, what would be my sine?
0.
Yep. 0. Cosine is -1. And what about my tangent? 0. Yep. Okay. Any questions on that one? All right. Okay, so the last one, I showed you this one as we were doing the notes. I said it would be the last one we do. So finish up and see if you can do that one on your own. Find the 6 trig functions of 11 pi over 2. Now, you only know how to find the coordinate if it's 0, 90, 180, or 270. These are the only 4 I've taught you. So somehow that must be one of those 4. So figure out which one it is, and then go from there. Okay, so let's we'll finish up. Take a look at what you guys did. Anybody tell me what did they do first here? Maybe something before we even start unit circle trig. Yeah, Jillian?
I converted it to degrees.
Yeah, I think it's a good idea because 11 pi over 2, it's probably a lot harder for people to figure out where it is than if we just put it in degrees. 180 over pi, cancel the pi's, and if I want, 2 goes into 180, how many? 90. And now 11 times 90 gives me how many degrees? It's 990. Now, even though it's in degrees, I still think that's kind of a hard angle to visualize. So what can I do to 990 to make it smaller? Ethan?
Take away 360.
Yep. We'll take away 360. And you do it as many times as you need to. Okay, so 990. Oops. 990. We'll do it once. That's not enough. Do it again. 270. And now, without making the diagram, does anyone remember the coordinate for 270? Yep. 0, negative 1. Right, so let's go through them quick. Tanner, my sine.
-1.
Yep. Lauren, my cosine.
0.
0. Cassandra, my tangent.
0.
Careful, you're dividing by 0. So it's -1 divided by 0. When 0's on the bottom, you get what do you get? Anytime you try to do like any number divided by 0. Sure. Sam, can you help Ro? What do you get when you divide by 0?
Undefined.
Undefined. Okay, some calculators do it a little differently, but if you try to divide by 0, this one just says cannot divide by 0. You can't do it. So we just say undefined. Okay, cosecant. How about Justin?
-1.
Yep, -1. Pacey, my secant.
Undefined.
Right. This is 0. When you flip 0, think of that as 0 over 1. It turns into 1 over 0. Can't do it. Undefined. And Sean, what about my cotangent?
0.
0. Yep. Perfect. Okay. Any questions on that? All right. So I'm going to leave you guys with the last 20 minutes or so, a little over 20 minutes to start the homework. It's in the book on page 116. 11 to 27, just the odds. The only even that I'd like you to try is number 22.